Thank you, Tony, and thank you, everybody, for joining us for this teleconference today to announce the U.S. Winter Outlook. Just a few pieces of housekeeping here. I'd like to introduce the speakers. We have two speakers today. Mike Halpert is the Acting Director of NOAA's Climate Prediction Center, and he'll be delivering the outlook. And then we have Kevin Werner. He is the Western Regional Climate Services Director with NOAA's National Climatic Data Center. And Kevin is on the line to address the California drought situation. Then we have two other scientists on the call to help with the Q&A portion. Deke Arndt, he's the Chief of Climate Monitoring at NOAA's National Climatic Data Center. And then we have Brad Rippey. He's a meteorologist with the U.S. Department of Agriculture, and we'll send questions their way as appropriate during the Q&A portion. Wanted to let everybody know that supplemental materials for this announcement are available right now at NOAA.gov. You'll want to look for the U.S. Winter Outlook news release. We have maps available on that website, and they are camera ready, and we also have some additional supplemental information posted along with the news release, and that's at www.noaa.gov. With that, I will turn the phone over to Mike Halpert.
Thanks, Susan. The National Weather Service plays an important role in helping the nation prepare for, respond to, and recover from extreme weather and climate events. Building a weather-ready and climate-smart nation is a collective effort to improve America's resilience to extreme weather and climate by empowering the public to make fast, smart, and life-saving decisions. We produced the Winter Outlook in order to give American communities the best possible scientific prediction of how we think the winter will shape up across the nation. The Outlook supports everyone, from local and state governments in their effort to plan for public need this winter, to large and small businesses as they plan for how this winter might impact transportation, market demand for their goods and services, etc. The Outlook is probabilistic in nature. That means simply that the maps that we'll show provide the areas that are most likely to be warmer or colder than normal or wetter and drier. However, it's important to realize the nature of a probabilistic forecast means that other outcomes are always possible, just less likely. Seasonal climate forecasting is a young and evolving science. The Climate Prediction Center uses a host of new scientific tools and partnerships to improve the accuracy of our seasonal outlooks. I'd be happy to answer questions about any of our new tools or any of our old tools for that matter after our prepared remarks. And if anyone would like additional details about the technical side of the outlook, they can feel free to follow up with me at a later time. Once again, and I know I sound like a broken record on this one, but we're not seeing strong climate signals and patterns that often give us clues as to what the season will bring. So the probabilities that we show on both the temperature and precipitation outlooks are modest. Sea surface temperatures across the equatorial Pacific have flirted with El Nino for about the last 6 months. And while El Nino has yet to fully develop, we do still think it'll occur in the next month or two, although probably as a weak episode. And once it develops, we do think it will persist into the spring. Of course, while providing potential clues as to what we may see this winter over the country, the winter impacts typically associated with weak El Nino episodes are not nearly as reliable as those we might expect to see with strong events. Therefore, while a lot of the patterns we'll show on the temperature and precipitation outlooks are consistent with El Nino, the probabilities assigned are lower than we might have issued if we were expecting a stronger event. Also, typically the highlights for winter revolve around the temperature outlook, how cold or how warm it might be. But the long-running exceptional drought dominating California elevates the importance of precipitation this winter. So having said that, I think I'll begin with the precipitation outlook. It does favor above average precipitation across the entire southern tier of the nation, from Southern California, across the southwestern, south central, and Gulf Coast to Florida, and then along the eastern seaboard, actually all the way up to southern Maine. Above average precipitation is also favored in southern Alaska and the Alaskan Panhandle. Below average precipitation is favored in Hawaii, the Pacific Northwest, and in the Great Lakes region. The rest of the country, including central and northern California, falls into what we call the equal chance category, meaning that there's just not a strong enough climate signal in these areas to make a prediction other than climatology. So these areas have an equal chance of above average or below normal precipitation this winter. Turning to temperature, that outlook favors warmer than average conditions out west along the U.S.-Canadian border eastward into New York and New England, and as well as for Hawaii and Alaska. Below average temperatures are favored in the south central and southeastern parts of the nation. The areas in between generally have, again, that equal chance category, meaning there's no tilt in the odds. At this point, I'll turn it over to Kevin, who will provide additional information on the drought in California.
Thank you, Mike. Good morning, everyone. My name is Kevin Warner. I'm the NOAA Regional Climate Services Director for the Western region. I'm happy to be here today to provide you with an update on the drought in California and the winter season outlook and what it means for our region. So I wanted to talk about three things. I wanted to first just talk about drought in California. I wanted to provide some information about the drought, and then I wanted to look ahead. So 3 points on drought in California. First is that 2014 is a continuation of dry conditions that we saw starting in 2012 and continuing in 2013. So if we look at the aggregate of those 3 years, 2012 to 2014, is the driest period in statewide, driest 3-year period statewide in the record. Second point, California climate is characterized by extreme variability between wet and dry, more so than anywhere else in the country. And to address that, to accommodate that, California has built an elaborate and expansive set of infrastructure to store and move water from distant places to where it's used. For example, the State Water Project can move water from Northern California through over 300 miles of canals to the much drier part of the state in Southern California. Third point, the winter precipitation is particularly important for that state, especially in the mountains. It's the deficits in mountain precipitation and snowpack that largely drive drought in California. So having said that, let me give you some information about the drought in California. I'm going to talk about precipitation, snow, rivers, and reservoirs. So first, precipitation. The Northern Sierra 8-station index last year for 2014 was 31.3 inches or 63% of average. The Southern Sierra 5-station index was 20.4 inches or 50% of average. And over the last 3 years, most areas of the state received less than 2 years' worth of their normal precipitation. For snow, the average April 1st snowpack across the state this year in 2014 was 9.4 inches of snow water equivalent, which was about 31% of normal. By May, the average snowpack was across the state was down to less than 10% of the average, and there was a very short green-up period and a very short runoff period that we hadn't seen in quite a number of years. For the rivers, the average runoff volume on the major rivers ranged from around 10 to 50% of average for the entire year. A couple of the key tributaries, the American Sacramento Basin was 30 to 45% of average, and the San Joaquin Basin, was 20 to 30% of average. For reservoirs, on August 31st, the 154 largest reservoirs in the state held about 13.5 million acre-feet of water. That's about 57% of average for that date and only 36% of capacity. The largest reservoir in the state is Shasta Reservoir. It only held 1 million acre-feet of water, which is only 25% of its capacity or 42% of its average for August 31st. Let me wrap up with a couple comments about looking ahead. The first one being that the drought is local. In California, the drought is highly dependent upon access to the storage and conveyance infrastructure that I mentioned. The more access there is to that infrastructure, the less vulnerable a particular area or locality might be for drought. Second comment is on groundwater. I haven't mentioned groundwater at all, but the groundwater has been significantly, in many cases, severely depleted this year, and therefore going forward is a diminishing resource that the state can count on for augmenting its water supply. So given all that, California is now exceptionally vulnerable to water shortages, if precipitation continues to be low, the situation is unlikely to change even if we get an average precipitation year. It will take significantly above average amounts of precipitation to refill reservoirs and recharge groundwater in the state. And this is unlikely under the forecast that Mike just presented. So with that, I'll pass it back to Susan to moderate the discussion. Susan.
Thank you, Kevin. So Mike gave you the temperature and precipitation outlook for the country, and Kevin talked a little bit in detail about California. But today we also issued the U.S. Drought Outlook, and Mike is going to take a couple of minutes just to give you a glimpse of the drought outlook for the rest of the country, and then we'll go into Q&A.
Yeah, thanks, Susan. And one thing I did want to mention about the drought outlook, it does cover a slightly different period. The drought outlook actually at this point only extends through the month of January, so it's really looking at the last couple of weeks of October and then November, December, and January. It does predict drought removal or improvement in some parts of California, mainly in the southern part and then the northwestern part as well. And we really haven't touched much on drought in the rest of the country. But we do see some removal or improvement across the central and southern plains, the desert southwest, and then there are some small areas of drought up in New York and parts of New England that we see improvement there as well. Drought is likely to persist in the remainder of California, as well as a lot of areas out west in Nevada, Utah, Idaho, Oregon, and Washington State. And given the expectations for a drier than average winter in the Pacific Northwest, we could see drought development in parts of northeastern Oregon, eastern Washington, and small portions of Idaho and western Montana. So that would be the drought outlook, and let me turn it back to Susan.
Okay, thanks, Mike. Tony, if you're there, we're ready for the moderated Q&A.
Absolutely. We'll now begin the question and answer portion. If you'd like to ask a question, just press star, then 1 from your touch-tone phone. Remember, your name is required to introduce your question, so make sure your phone is unmuted and record your name clearly when prompted. One moment for our first question. And our first question comes from Seth Borenstein of the Associated Press. Your line is open.
Yes, I have two questions, one for Mike and then one for Deke, which is basically what's missing in this call, which is this, the September global climate figures. Where are they? What are they? Why aren't they here? There's no briefing like normal on the monthly thing, so if you can fill us in on the monthly records, Deke, that would be good. But for Mike, just looking at this forecast and given especially last year's forecast that didn't do so well, is it fair to say you're expecting sort of not a memorable winter, sort of a run-of-the-mill winter, a little warmer here, a little cooler there, a little wetter, dry, but sort of not one of these winters for the ages, or like last year's?
Yeah, Seth, those kinds of really extreme type winters are really the ones out in kind of the tails of the distribution are pretty much impossible to forecast, and really what we're forecasting here is average conditions over a 3-month period. So, would we say we would not expect to see a repeat of last winter? I would certainly agree with that. Is it impossible to see another very cold winter in parts of the country? Certainly that's possible. Our outlook certainly doesn't favor anything like that. At this point, the areas most likely to be below average are in the southeast. And really when you see, a pattern that looks like what we're forecasting, we're not typically dealing with Arctic air that's kind of intruding just into the southern part of the nation. Obviously, for it to get there, it would have to pass through the northern and central part of the nation, and at this point, we're not seeing really strong signals that would indicate those areas would also be below average this winter.
And Deke?
Hi, Seth. The global report for September, we'll issue that on Monday. And you should see it Monday morning around 11 o'clock.
All right, then just a follow-up from Mike. I just want to make sure I get this right. You're not seeing sort of the intrusion of the Arctic air as much like last year. So, does it look like a polar vortex, that we all learned about last year might be taking much of the winter off?
Seth, again, that's kind of getting into more weather-type features. Now, last winter, obviously, we saw very cold air outbreaks, very persistent. At this point, there's nothing that indicates we'll see a repeat of that. I would certainly expect at some point during the winter we will see some cold air enter the country. I mean, that's what winter is known for. But the likelihood that we see it as persistent as we saw last winter, I would say, is fairly low.
Thank you.
Our next question comes from Doyle Rice of USA Today. Your line is open.
Good morning. Thanks for doing this call. Staff kind of asked one of my questions, which was just on your press release. You did lead with the fact that a repeat of last year's extremely cold, snowy winter east of the Rockies is unlikely. And I guess, how are you so confident in saying that? Well, that's kind of my first question. And the second one is, do your forecasts at all include any of the recent kind of studies and research into Siberian snow or in some of the changing atmospheric kind of the wave pattern changes that are taking place over the Arctic? I just wondered if that is included in this forecast.
Sure. Let's start with the first question. And again, the persistence of the cold from last winter, it was actually contributed from a pattern over the North Pacific. It's kind of what we call a teleconnection pattern. So it's something that we observe, but we really, I think last year was a record strength of it, again, for its magnitude as well as persistence. So it's just really unlikely to see that. There are certainly there are differences across the Pacific. Right now we're flirting with El Nino, and we think we'll see El Nino to develop over the next month or two. And should that happen, it will certainly change what goes on across the Pacific. Typically, when we see El Nino, even the weaker ones, we see warmer conditions. If not in the U.S., we see it up into parts of western and central Canada and Alaska, and so that again would make that really cold Arctic air that would have to spill down through that area into our country less likely. So again, the idea of seeing a repeat of last winter is just not particularly likely. I said I would never say anything's impossible, but I would say certainly unlikely. As far as the issues of snow cover over Siberia, it's certainly something that we're well aware of and we're looking at. The real challenge with leveraging something like that is it's a really limited sample size in terms of the number of years we can go back on and analyze and train tools on. So while they do seem to have some amount of skill in forecasting things like the Arctic oscillation, it's fairly modest skill, and it's possible that it could be skill that just is leveraging things like decadal patterns of the Arctic oscillation, which is something that we're aware of that does exist. So while we're aware of it and it's acknowledged, and just for those, if they're interesting, it looks at this point like it would favor the way things are evolving, a negative Arctic oscillation, and so some of that maybe goes into the forecast we have for tilting towards below average temperatures in the southeast. It's not a strong tool at this point, and the reality is that if it becomes a strong tool, we'll probably end up having to move this press telecon into November, because really it's looking at the whole month of October, and we're only in the middle of October right now. So while I know that there's been some discussion that there's been a lot of snow piling up in Siberia right now, there's certainly no guarantee that continues through the rest of the month, and so we would kind of be making a forecast using it based on only partial information.
Thank you.
Our next question comes from Craig Miller of KQED. Your line is open.
Thanks, and this is pretty much for anybody who feels best qualified to take it. Is there any way to handicap, and this might be getting into that weather area too, but is there any way to handicap what might happen this year with this persistent blocking ridge that parked off of California last winter and diverted most of our storms away from the state? Is some kind of a guess at that factored into your so-so forecast for precipitation for California this year?
I think I'll take that. I think it relates probably more to the precipitation forecast as much as anything. Certainly we look at potential circulation regimes as we issue our forecast. The development of El Nino would certainly not favor that type of a ridge along the coast. That's kind of one of the things we would see is that if there's any type of a ridge, it's maybe a little further to the north, which allows precipitation to at least get into the southern and central parts of the state. Again, what made last winter so remarkable, I would say, wasn't necessarily the pattern that we saw at various times. It was that it was a very persistent pattern. I mean, even in kind of noteworthy cold winters of the past, and you don't have to go back that far, at least for the eastern part. You can go back to the winter of 2009, 2010. It wasn't, we had like December and February were very persistent, but January broke down. I don't think, especially once we got through the middle part of December, we really had a persistent pattern that, lasted through the winter into the spring. I mean, even into the spring, we were still here in the D.C. area, we were still dealing with cold and snow on St. Patrick's Day. And that type of a persistent pattern is just, it's just not really what we see in terms of natural climate variability. There's usually far more variance that goes on.
Okay, so I'm sorry, I'm trying to distill that down to the blocking ridge. It sounds like what you're saying is that's less likely to happen this winter.
That's correct.
Okay, and I'm sorry, which guy was talking?
Oh, I'm sorry, this was Mike Halpert.
Thanks, Mike.
Our next question comes from Andrea Thompson of Climate Central. Your line is open.
Hi, yes. Just with this expectation that if the El Nino forms, it will be a weak one, and given what you guys are saying about warmer conditions and less precipitation in California, what do you think is the best case scenario that California could see this winter?
Best case scenario. Well, I said, given a probabilistic forecast, certainly an above average rainfall season is not out of the cards. El Nino is not the only game in town. We could see Madden-Julian oscillation impacts play a larger role than we think. That potentially could result with more rainfall, and it could be wet up and down the entire state. That's kind of a best case. It's not, again, the favored case. The favored case is really in the central and northern part of the state, anything. Now, we do see, as I mentioned, in terms of the drought outlook, some improvement in maybe the northwestern part of the state. Remember that the winter is obviously the wet time of year in California. So this is when they need to see their rainfall, and we don't try to forecast amounts for sure, but when you're talking a best case, you could get into a situation that is wetter than we're maybe leaning towards, but things aren't out of the question. I still would say, given the magnitude of the drought that's there, even in a best case, there's still going to be serious drought in large parts of California when the winter's over.
Great. And that was nice.
Yes.
Our next question comes from Rob Cheney of the Missoulian newspaper. Your line is open.
Thank you. I'm up here in Montana, and I was hoping you could give a little more detail on what you're seeing for the Pacific Northwest as far as the impact of the El Nino or whatever other force you might see developing up here. And in particular, is Montana on the split line between your Pacific Northwest and your different conditions for the Midwest? I'm also wondering if, a second question, if the impact of the California drought is going to have any ripple effects to other areas of the river watersheds, particularly up here in the Pacific Northwest, if you're going to see changes in our groundwater or the water demands up here.
Sure. Let me take the first one, Kevin, when I'm finished, if you could maybe take the second question. As far as the outlook for Montana, when we talk about the Pacific Northwest, so that at this point is covering maybe the western half of the state with regards to precipitation. So we do favor below average precipitation over the western half of the state. The eastern half of the state is equal chances. Temperature-wise, there is a tilt towards above average temperatures covering the whole state, with the most likely area, again, that western half of the state. Having said that, I'll turn the groundwater question over to Kevin.
Yeah, good question. Thanks, Mike. There isn't a lot of connection between the Pacific Northwest and California in terms of infrastructure to move water, either on the ground or the surface between those regions. There is infrastructure to move water out of the Colorado Basin that drains, Wyoming, Utah, Colorado, Arizona, New Mexico, and Nevada into California, and that is a very significant part of the state of California's water portfolio, and that's also been responsible for mitigating the impacts of the drought in Southern California as they've been drawing heavily on California water this past year. But between the Northwest and the Southwest, there really isn't a similar infrastructure.
Our next question comes from Jed Kim of Southern California Public Radio. Your line is open.
KQED asked my question, but I guess I would like to follow up and ask. Right now, is that high pressure ridge that was the bane of California's existence last year, is that there right now?
No, I believe that has broken down. I think even over the last week or two, there's been some decent rains into at least the northern parts of California and up into Oregon and Washington. So no, at least currently that ridge is not involved in the overall weather pattern.
Okay, thank you.
Our next question comes from David Castellan from the Visalia Times Delta. Your line is open.
Hi, Visalia, by the way. Gentlemen, first of all, one of you earlier was talking about best case scenarios. You did not identify yourself. Who was that?
I'm sorry, that was Mike Halpert.
Okay. Thank you. It's really important that you guys identify yourselves so we know who's saying what. My first question has to do with it's California-centric. Last month in your report, you folks said that there was a likelihood of a light winter here in California and a warmer than normal winter, and now you're saying it's pretty much one-third odds it could go any way. But then another speaker says it's most likely we're going to still be in drought conditions. Can we clarify that in terms of temperatures and rainfall for California? What are the expectations?
Sure. This is Mike, and I'm sorry if there was confusion here. I actually don't think the forecast for California has really changed that much. For temperature, the entire state does favor above average temperatures. For precipitation, there's a slight tilt towards a wetter than average winter across maybe the southern third to half of the state.
From where to where?
My geography is not the greatest. It's certainly south of San Francisco, maybe 100 miles south of San Francisco. Through the rest of the state, there's a tilt towards above average precipitation, and then north of that line, it's what we call equal chances, so that it's a one-third. As far as the forecast for drought, because it is the wet time of year, there is even normal rainfall, at least in the northwestern part of the state. That would probably result in some improvement, and as well as in the southern part of the state, the very southern part, where we've actually have had some rains over the past, really even during the summer. We had probably maybe a little bit of surprising rains. And that area is the area that's favored to be wetter than average, but probably the large majority of the state we do favor persistence of the current drought conditions.
Our next question comes from Matt Weiser of the Sacramento newspaper. Your line is open.
Thanks. It's Matt Weiser with the Sacramento Bee. I was just hoping you could comment a little bit about the interaction between the precip and temperature forecasts. In other words, if you're showing equal chances of wet or dry but warmer conditions. Does that mean that it's likely more of our precipitation will come as rain rather than snow?
This is that one's mine. Not really. While there are tilts to this, certainly if you're talking up in the mountains, I would imagine they're high enough that even with above average temperatures, a lot of that's still going to fall as snow. I mean, maybe the snow levels will be up a little higher. But really now you're getting into kind of the weather aspect of things and the timing aspects of things. And certainly, the warm areas could occur when it's not precipitating, and so when you're getting the storminess it's providing, in particular in the northern part of the state, certainly a lot of that precipitation could fall as snow. Really, you're getting now into weather, and the science really doesn't allow us to say much about that.
Okay, and if I could ask one quick follow-up, how does the Pacific Decadal Oscillation figure into the predictions you're making today? The Pacific Decadal Oscillation is kind of a modulation, or it's what we view it as decadal variability of El Nino. So how it impacts things, it's probably impacting this El Nino that right now, is struggling to get going, because we really have been in kind of the negative phase of the PDO, which really favors La Nina. So, this is all kind of evolving in science, so I don't have, hard and fast answers for you, but my gut to that question is just that the impact of the PDO we're seeing has been more this decadal variability on the tropical Pacific, and so its impact on El Nino. Okay, thank you.
Our next question comes from Tom Puckett of WBEN Buffalo. Your line is open.
Thank you. Good morning, gentlemen. Last year, the Buffalo region saw 2 blizzards. Obviously, it does not look like this will happen again. But what does the precipitation outlook and the temperature outlook specifically look for the western New York, eastern Great Lakes region?
So western New York temperature, we have a tilt towards above average temperatures. In our 3-class system, maybe it's around a 40% tilt towards above average temperatures. Precip, you guys kind of split the gap in between a tilt towards below in the Midwest and a tilt towards above along the eastern, the coastal region. So no tilt towards on the precipitation forecast for Buffalo.
So pretty much it's pretty much a toss-up as far as how this winter will go.
With regards to precipitation, like I said, we do have a tilt towards a warmer than average winter.
And I know that El Nino, how much of an effect generally does El Nino have on the eastern half of the Great Lakes, which includes western New York?
The stronger signal with El Nino is probably back to your south and west, maybe the Ohio and Tennessee valleys. So the signal into western New York, that dry signal, every El Nino is different. So some years the setup can be favorable for it to be drier. This year, given a weaker type event, might not have that much impact on your area at all.
All righty. Thank you very much.
Hi, this is Susan. We have about 10 more people in the queue to ask questions with about 20 minutes to go. So if I could ask you please to limit your questions to just one question with no follow-ups. You're welcome to email me at susan.buchanan@noaa.gov, and we'll take care of your questions after the teleconference. Thank you.
Our next question comes from Corey Reppenhagen of 7 News KMGH. Your line is open.
Yeah, I was wondering if you guys had anything specific to say about the Colorado region, and if you could explain for those of us in the equal chance areas why our probability doesn't really sway one way or another despite a changing ENSO pattern. Thank you.
The ENSO pattern over Colorado is actually, again, during the heart of the winter isn't that strong. I think the signal would be a little later on in the spring. So remember, we're focusing here on December, January, and February.
Certainly, if this event does develop, you might expect to see a tilt towards above average precipitation as we get into either JFM or FMA. Temperature, there's not really a strong link between El Nino and Colorado temperature, and really the other tools we're looking at for this winter didn't really have a strong signal one way or the other, and so that's pretty much the result of the equal chance temperature forecast for Colorado.
Thanks, guys.
Our next question comes from Benjamin Spillman of the Reno Gazette-Journal. Your line is open.
Hi. I am wondering, it seems like our region kind of falls between Southern California and the Pacific Northwest. I wonder if you could talk a little bit about kind of Lake Tahoe, Sierra Nevada, and kind of east through northern Nevada, please.
Are you looking for the precipitation forecast or more?
Yeah, the precipitation forecast and the temperature.
Okay. Well, temperature again, pretty much the entire west.
Kevin?
I'm sorry. This is Mike. I'll try to remember to identify. So temperature again, the entire west is favored to be warmer than average this winter. Reno area is pretty close to the 50% line, so a pretty decent shift towards above average temperatures. The split in the middle between the dry to the north up in the Pacific Northwest and the wetter to the south, that's oftentimes kind of a hallmark of the kind of the moderate or the average strength El Ninos. Oftentimes the real strong ones, at least the couple of cases we've seen, the jet stream across the Pacific becomes so strong that it largely becomes wet everywhere. When you deal with stronger ones, the exact location of kind of who benefits from that Pacific jet stream becomes less certain, and so somewhere through the middle, we'll end up maybe on the wetter side versus the drier side, but there's really no skill at long leads like this as kind of finely depicting where those areas are going to be.
So should I buy a season pass in Tahoe for skiing or no?
Can you repeat real quick?
Should I buy a season pass in Tahoe for skiing or not?
That's a question that I'm going to pass on.
All right, thank you.
Our next question comes from Hobble Smith of the Kingman Daily Miner. Your line is open.
All right, Mike, so we saw a pretty mild winter here last year as far as temperatures, but we did see a pretty good monsoon season with above average drought, above average precipitation. You did say that the El Nino is going to be weak. Can you tell me, is it going to bring any rain, and how much rain will it bring?
That kind of gets into the areas where science really doesn't allow us to give more specific answers than what we're able to tell you. I'd love to give you a number even, but that's just not the reality. Certainly, the entire Southwest is favored to have above normal precipitation. How much above? Now you're getting into individual extreme type events, and we just can't really go there. Like you mentioned, the monsoon was very good this year. Actually, even though El Nino hasn't developed, I think there was a link to that with all of the tropical cyclone activity in the eastern part of the Pacific. Certainly played a role in that. But other than tilting you towards above average precipitation, I can't really give you more than that.
Okay, thanks a lot.
Our next question comes from Rebecca Stevenson of Al Jazeera America. Your line is open.
My question is regarding, you were talking about the teleconnection of the contribution of the North Pacific, the record strength of the warmer temperatures causing the polar vortex or an indication of that type of signal. And it seems that we tended to stay within sort of a pattern of the cooler air on the east side of the U.S. and warmer, drier to the west. But the indication of the October through January forecast is almost the opposite of that pattern. What is it that's indicating to you that that's going to be changing in this period of time?
Well, let me just say when I was talking about, I think you're comparing to last winter and
yes.
Right. Okay.
And,
so
and over the summer and currently, it seems to sort of it's not as extreme, of course, in the pattern, but it's very similar.
Right. Well, and actually, I think maybe you're referring to the sea surface temperatures, the ocean temperatures, and when I was talking about the North Pacific oscillation, it's actually an atmospheric pattern. The link between that, basically, that pattern caused the ocean temperatures to be as warm as they've been. Actually, they've been cooling over the last month because that pattern has broken down and doesn't exist right now. So, could it come back? Sure, it can come back. I wouldn't say that our outlook is orthogonal to what was observed last winter, certainly. I mean, last winter was also cold in the south central part down into Texas, and so we do favor that, not from the same type of a pattern, but we do, see cold in some areas that had it last winter. If you're talking about the areas like in the northern plains, which is really where the heart of the cold was centered last winter, again, that's looking at a very, very extreme type of a case, and it's just, that pattern is gone right now, and the expectation that we would see a second year in a row of that, especially given that the tropical Pacific is somewhat different from what we saw last winter. It's not likely to recur as we saw last winter.
Okay, so you are seeing that warming of the temperatures along the Pacific, or the blob, so to speak, up into the northern Pacific as impacting the forecast you've made here.
Well, like I said, you're kind of maybe confusing the ocean with the atmosphere there. I mean, there can be a link to them, but it's actually the atmosphere that's kind of forcing the ocean, not the other way around. And so as that pattern that we saw for, really the winter into the spring and even parts of the summer resulted in very warm ocean temperatures. But as we've seen that pattern evolve into something else, we're now starting to see the ocean cool. And if that pattern doesn't recur, we'll see the ocean cool fairly significantly, would be my guess, over the next couple of months. And so a wintertime pattern that could be much different from what we saw last winter.
Okay, so to clarify, you're saying that the atmospheric is what influenced the ocean temperatures to warm, and
right.
Then now that's not such a strong signal, correct?
Well, the atmospheric pattern that we saw last winter, right, is not present any longer. That's correct.
Okay, we need to move on to the next question, please.
Our next question comes from Dean Jackson of WOWO Radio. Your line is open.
It's going to, from what I can tell, a mild winter in the Midwest and much of the Great Lakes. What are you seeing in terms of the model for the Great Lakes, and what are the chances for an extreme event to happen? What would it take for that to happen?
You mean like one extreme event?
Any type of extreme activity. You said they were pretty low. What would have to happen for that to be?
Well, what I said was low was for the persistence of a very long, multiple month pattern where it stays cold for the entire time. It's just unlikely. I said we never rule anything out. What would have to happen? Well, we would have to have, for some reason, again, the circulation would have to kind of lock into a mode that favors that and then just doesn't break down. To me, it's unlikely to see that type of a pattern. Things are much different. It's a year later. The tropical Pacific is much different. The North Pacific is different. We just think that's an unlikely solution. But having said that, I would expect, you live in the northern part of the United States, I would expect there to be some cold weather this winter.
Our next question comes from Brian Bledsoe of KKTV 11 News. Your line is open.
Thanks for doing this. First of all, I'd just like to say that, a lot of folks that are trying to put all their eggs in the El Nino basket, I would strongly urge caution against that, especially when there's a weak signal. I'm sure you guys could attest to that as well. But also for my own work, doing it analogs as far as past years looking very similar to this year, one, I cannot find a perfect analog for that, nor, did I really expect to, but looking at close analogs, there is a pretty good signal of what to expect. And I'm curious why you guys don't readily mention those analogs, or maybe you do have those in mind and just don't mention them. Can you clarify that for me, please?
Sure. Analogs on the seasonal time scale, I'll be fairly honest and say is something that we put very little weight in, mainly because, when you're looking at a winter forecast, you get one winter a year. And, there have been some that show that to have like a complete set of analogs, you need thousands of years, if not even multiple thousands of years, to really have the full set of analogs. So, we've got a set of, if you're charitable, say 100 years, nowhere near enough cases. You want to look at a great example for kind of the failure of an analog. Just go back to, we talked about El Nino, go back to the spring, March and April. Everybody saw the subsurface evolving in a way similar to what happened in 1997, and there was a lot of talk that here came the next 97, 98. Clearly that sample size of prior El Ninos wasn't enough to give us all the possible outcomes, and really that's the case for seasonal forecasting as well.
But weren't those occurring in a different phase of the PDO, both 82, 83, and 97? PDO was a blowtorch, and since that shift, we shouldn't have had a super El Nino at that time, if you're analoging correctly, am I right?
I don't know, to be honest. 82, 83 was before we were even forecasting El Nino. We didn't really know much about it. 97, 98 was certainly in the other phase. But I don't want to get into a long debate since my public affairs person is saying we need to move it along. Let's just say that to do analogs on seasonal timescales, you need thousands of years, and we don't have the data to do that.
I appreciate your time.
Okay.
Our next question comes from Todd Fischette of the Western Farm Press. Your line is open.
I think this is kind of for Kevin because he talked a lot about river watersheds. Let's talk about the Colorado River watershed. It's really large, spreads over a large area of the West. Generally speaking, does it favor a wetter year so that we can capture runoff and move that water to where it goes, and particularly that watershed, but even some of the others? You mentioned the American River, the Sacramento River, and talk a little bit about those.
Sure, this is Kevin. So you're asking if this upcoming year favors a wetter year in the Colorado?
Correct.
So as Mike talked about, the climate forecast is for equal chances across most of the Colorado River Basin. Did want to emphasize one point, that it's really the mountain areas in the winter that receive snowpack that drive drought and water resources across the West. So looking both in California and in Colorado, it's a very small portion of the basins that we look at for driving the water resources picture. In the Colorado River Basin, we're looking at the Rocky Mountains in Colorado, and then we're looking at two other mountain ranges in Utah and Wyoming primarily that account for 80% of the water in that basin. We'll make a comment on the Colorado River. Since the year 2000, we've had 15 years now. Only 4 of the last 15 years have been above average. 2 of those years have been very near average. So for the most part, we're in a long-term drought on the Colorado River. The Colorado has 2 of the nation's largest reservoirs, like Powell Lake Mead. They are collectively less than half full right now. So it would take multiple wet years to recover in the Colorado River for this very long-term drought that it is experiencing. In any one year is just not going to be able to fill those reservoirs, even if it is very wet.
Okay, thank you.
You're welcome.
Our next question comes from Becky Oskin of Live Science. Your line is open.
Hi, thanks. I wanted to ask you to expand a little bit more on the connection or the interplay between El Nino and its effects on the polar jet stream and how the polar jet stream is able to dip down into the eastern United States during the winter, and how El Nino conditions can prevent that or make that harder to happen.
Well, it really depends on kind of how strong your whole patterns are. In the kind of what we call the canonical El Nino sense, really across the Pacific, you end up building a jet stream that might be much wavier,
And when you get things like that, oftentimes you'll see kind of a retraction of the polar jet northward. And so obviously when that happens, you don't get that delivery of cold air. The classic case for that would have been like the winter of 97, 98. Of course, we don't expect to see an El Nino like that this winter. So, it's also possible that they kind of interact together and the southern jet provides kind of the fuel and the moisture, and the cold air delivery comes from at least periodic excursions, and you end up with a lot of snow up, in the mid-Atlantic and Northeast. We've certainly seen winters where that's happened as well. Right now there's no real strong indication, especially as we're still waiting for El Nino to develop. So it's really not clear as to which will kind of become the dominant role this winter.
Our next question comes from Henry Gass of the Christian Science Monitor. Your line is open.
Yeah, hi. My question's actually been answered, so you can move on.
Our next question comes from Brandon Beck of KYTV. Your line is open.
Good morning, guys. Thanks for doing this call. Given that last winter turned out to be so much colder, especially over the eastern part of the country than was expected, have you gone back and been able to identify, some of the contributing physical drivers to that cold? And do you see any similarities or changes in the pattern that's leading up to this winter?
Well, I think I mentioned that a lot of the resultant pattern over North America kind of was driven out of the North Pacific. Certainly we didn't, as we went into the winter, expect to see that. I mean, we didn't see it going into the winter. We don't see it going into this winter right now. So the expectations again aren't for it to play a major role. I mean, it's something that, if you look back over the last 50 years, it probably rarely plays a major role. We're still kind of looking into research as to maybe what drove that. We don't have real firm answers at this point. But, again, when you see extreme patterns, the expectations are that they won't repeat year after year after year. I mean, if they do, then there's something really kind of, can't think of the right word, but there's something that's driving that. And certainly, in one sense, is probably beneficial, because if it keeps happening year after year, I suspect we'll be able to uncover it.
Thank you.
Our next question comes from Marianne Thomas of the Valley News Dispatch. Your line is open.
Mike, earlier you talked about season forecasting is a young science, and I wanted to understand, how accurate the season forecasting is. Example, were you able to nail the severe winter weather in the Northeast last year?
Well, no, we didn't. To be honest, I'm not even sure. My guess is our forecast last winter for the Northeast was equal chances. So we certainly we didn't favor a warm or a cold winter. Obviously, we ended up with the cold side of things. Mm-hmm. In terms of accuracy, really, when you're dealing with a probabilistic forecast, you wouldn't expect to always be right. What you're trying to be is reliable. And so if we give a certain probability of an occurrence, that's how often we'd like to see it happen. In general sense, compared to just kind of a random forecast, we're, I think, in the neighborhood of 25% better than that. So obviously there's room for improvement, but there is certainly still value there. In terms of infancy, the models that we use, we're looking at maybe the second or third iteration. The weather models are probably on their 20th or 30th iteration. So there's still, a lot of hope that as we upgrade models in the future, that will end up having more reliable forecasts.
Thank you.
Our next question comes from Lee Bourne of KNAU Arizona Public Radio. Your line is open.
Hey, good morning. My question has to do with our precipitation here in the Southwest, and I would like you to talk about how weak El Nino forecasts differ from a moderate or strong El Nino forecast. Here, I've seen a set of data here in northern Arizona where actually in weak El Ninos we've been below average more often than not, and here in this season, we're actually in the broad brush tilt towards a wetter season. So how does a weak El Nino weather pattern and probability forecast differ from a moderate to strong?
This is Mike. If we had like a strong event, and you can go back and it's on our website, but for the 97-98 event, the probabilities for above normal precipitation, I think, were 70 or 80%. So that's where you would see the big difference is that we would be far more confident. It would be a far more likely solution than what we're seeing here with a weaker case, where we kind of just have you're just barely into the favored wet conditions. El Nino is not the only kind of game in town. I mean, these forecasts, while El Nino is an underpinning for it, but we also have our computer models, and the models are indicating above average precipitation in there as well.
Because with the weak El Nino, we do see a signal for a stronger subtropical jet?
That would be part of the link, sure.
Okay, and then one other question on the drought monitor and kind of the Colorado, working the southern end of the Colorado River Basin. And our reservoirs are at like 25% as well. And, I've been forecasting weather here in northern Arizona for a long time. And since 95, we've been talking about a long-term drought here in northern Arizona with our reservoirs at like 25% of normal. And, of those 20 years that we're looking at this long-term drought, only several years, we've only had a handful at average or above average. And if you look at the water deficit, we're 3 or 4 years below water deficit. I see on the drought monitor that, we could have removal of drought. And I've always been confused with what does it take, and this is the same thing for California, what does it take to remove a long-term drought? Does one wet season do it? And, it seems like a lot of times on the drought monitor, we're in drought, we're out of drought, we're in drought. I know there's short-term and long-term, but what does it take to remove a long-term drought?
Do you want me to take that, Mike, or do you?
No, I was actually going to see if you or Deke wanted to take that.
Sure, I can comment on that. I worked quite a lot in the Colorado Basin, and I think your observation is spot on. The drought monitor is pretty effective at short-term, perhaps medium-term drought, but really does not, it's not effective when we're looking at decade-long drought, as we're seeing in the Colorado Basin, and as certainly you're seeing in northern Arizona. So I agree with your point.
All right. Well, and then I know you're short on time, so I'll just...
Yeah, we really need to move on to the next reporter. I'm so sorry.
Our next question comes from Will Houston of the Eureka Times-Standard. Your line is open.
Hi, thanks for taking the time. This question is for Kevin, and pertaining to California's reservoirs, especially in the northern portion of the state. What was the rate of depletion of these reservoirs over these last 3 years of drought? Was it a slow and steady drop, or was there certain spikes that just dropped down? And then should this drought continue, especially with groundwater being depleted in Central Valley? What will these reservoirs look like a year from now as reliance on northern water continues?
So this is Kevin. Good questions. I would say that the rate of depletion on the reservoirs has been variable. My comment earlier about drought being local, every reservoir has different sets of demands and rule curves that are applied to it, and you really need to sort of drill down to specific reservoirs to get the level of detail that you're asking for. I would say in general, there's been a downward trend, certainly over the last 3 years, as we've seen dry conditions in the state, and especially over the last year, it's been extremely dry in 2014. But the way that's manifested itself in specific reservoirs varies from one to the next. Your question about groundwater is a really interesting question that we don't have the answer to. Groundwater is fairly poorly understood in California. As I'm sure you're aware, the state's recently passed legislation to monitor and look at groundwater in new ways, and I think that will provide effective data to answer that question in the future. But right now, we really don't know, speaking broadly across the whole state, what the impacts of the groundwater deficit will be going forward in its interplay with the precipitation this winter.
And then just my last question you didn't answer, just the future, the look at the reservoirs. Will the drop continue as it's, I think it's in 35%, you said, will it keep going down? And I guess what's the level you're thinking it's going to be?
and I don't have a specific level for a specific reservoir that I can talk to right now. I will say that the drought monitor and the drought outlook that Mike talked to that expects the drought to continue across most of central and northern, especially eastern California. That's exactly the region that's most important for water resources. That's where the mountains are. That's where the snow collection is. And if we see average or below average precipitation in that region, we would expect to see many reservoirs continue their downward trend.